Alright, I'd like to start off this video with a little warning, a little public service announcement. You have learned how to take some derivatives. You've learned the basic rules, the power rule, the trig rules, and the chain rule, which really expanded what you could take. I'm here to tell you right now the derivative of x squared times sine x, y prime, is not equal to, stress the not, 2x times cosine x. Okay? Your derivative taking powers do not include the power to take the derivative of two things that are multiplied together and just take their separate derivatives. F prime of x on the right is not equal to the derivative of the top 2x over the derivative of the bottom, which is 2x, or 1. That is not how you do these. The purpose of this video is to teach you if you've got a function that is two separate functions multiplied together or two separate functions divided by one another, you cannot just take the derivative of the two separate parts and leave them multiplied or leave them divided. Here we're going to fix that problem. Okay, I'm going to start with what's called the product rule. So if we have a function that can clearly be, I don't know about separated, but it's clearly two different functions that are multiplied together, like x squared sine x. Here's how we handle this problem. Y prime equals, and don't get hung up on the f and the g. That's just notation for two separate functions. The derivative of a product is the first function times the derivative of the second plus the second times the derivative of the first. And you might see that in a different order where you go second times derivative of the first plus first times the derivative of the second. That doesn't matter because we could change the order of this addition. What's important is that you do one of them times the derivative of the other and then add to that the other times the derivative of the one. So for our first example, we learned what not to do on that opening slide. Here's what we do. I do it in this order. Take the first, which is x squared. Okay, I've got two distinct functions here. And then I take the derivative of the second. The derivative of sine is cosine. And then I add to that the second times the derivative of the first, which is 2x. All right? And as these things get more and more complicated, a part of the hassle is going to be how do we simplify it when it's over with. There's not a whole lot that can simplify here. Maybe you could move this 2x to the front and make it x squared cosine x plus 2x sine x. And I'm not telling you that because I really want you to move that for me, but if this is a multiple choice question, just realize that that 2x could have been moved to the front so you can find your matching answer. So there's the product rule. All right, so this is called the quotient rule. A little bit more complex, but manageable. If you've got two separate functions, one on top of the other. The rule is this. Y prime, the derivative of this quotient, would be the bottom function times the derivative of the top function minus the top function times the derivative of the bottom function, if it were only that easy, over the bottom function squared. All right. And the way you can remember this one is if you consider, if you call the function on top high and the one on the bottom low, I don't know that's not how you spell high and low, but you can remember it with y prime equals low d high, and that d high is derivative of the top function, minus high d low over low squared. All right, so that might just help you remember the quotient rule. So let's work this example. The derivative of x squared over x squared minus 4 is the bottom times derivative of the top, which is 2x, minus the top which is x squared, times the derivative of the bottom, which is 2x, all over the bottom squared. So if I multiply out a little bit, I get 2x cubed when I distribute this 2x minus 8x minus 2x cubed over x squared minus 4 squared, or just negative 8x over x squared minus 4 quantity squared. And that is as simple as that one can get. Okay, so our next slide is 2 examples of product. You should pause here and try these 2, and then come back for the answers. I'll give you a second to do that. All right, so y prime, we've got 2 distinct functions being multiplied together. So I do first times derivative of the second. Now I'm going to put brackets because this is going to involve some parentheses itself. Remember that this is the first time this is going to happen, where the product rule involves the chain rule as one of those derivatives. My first function is x. My second function is this square root. When I get to the derivative of that second function, that involves a chain rule. So the derivative of 1/2 x squared plus 3 is 1/2 x squared plus 3 to the negative 1/2 times 2x. All right, that's the derivative. That's the chain rule part. All right. So my f times g prime involved a derivative for the g prime. All right, plus second function times the derivative of the first function. The derivative of the first is just 1, so that didn't really affect anything. All right, so now the derivative is taken. At this point, I have the derivative. I just need to simplify what I can. Looks like I've got a 2 here on the bottom and a 2 on top that can go away. I have an x and an x that can combine to make an x squared. And I'm going to take that negative 1/2 exponent and put it on the bottom and make it a square root to simplify that first part. So there's one simplification. Cancel the 2's, combine the x's, move down the square root. And then maybe what will happen is these 2 things can be added together. If I multiply this second part by the square root over itself, then on the top, now I've got 2 fractions that I can combine. I've got x squared over the square root plus x squared plus 3 over the square root, which combines to make 2x squared plus 3 over the square root of x squared plus 3. So don't be surprised if all of that happens after the fact. Usually students' frustration with this material is not getting from line 1 to line 2, but it's getting from line 2 to line 3, 4, 5, getting through all the algebra that follows afterwards. So be careful with that. We'll do this quick trig one. First times derivative of the second. The derivative of cosine of something is negative sine of something. But since that something has a derivative, I've got a times 2. All right, so the chain rule is happening here as well. Plus second function times derivative of first function. Derivative of sine is cosine. And there's that. So we've got negative 2 sine x sine 2x plus cosine 2x cosine x. Don't try to combine those to make a sine squared because they have different arguments. So not the same, so they're not something squared. All right, so there's two good solid quotient rule problems, product rules, and let's try a couple quotient rules. Now, quotient rule, a little bit more involved, but like I said, it's manageable, and usually it's the algebra that's the frustrating part, so don't be intimidated by the algebra. The rule says HODI high, so y prime, HODI high, that's the bottom. You can say low-D high, if it, low means more bottom, but either way, HODI high is x minus 1 times 2 minus high-D ho, 2x times 1, the derivative of x minus 1 is just 1, over bottom squared. There we go. So filling into the derivative formula is not that bad. At this point, we've got to do some algebra, and it's not that bad either. Get 2x minus 2, if I distribute that 2, minus 2x over x minus 1 squared, or negative 2 over x minus 1 squared. All right, there is the first quotient rule. Let's do another one. This one's got trig in it, and it's going to have a chain rule in it. HODI high, bottom, times derivative of the top. Derivative of sine is cosine. Chain rule times 2. Don't forget that chain rule. Don't get so focused on your new rules that you forget your chain rule. Minus top times derivative of the bottom is 2x. The bottom squared is x to the 4th. All right, so I do see one thing that can simplify here. All three terms have at least one x in them. So I'm going to take an x from here, leaving that x to the 1st. I'm going to take one from here, leaving that as x to the 3rd. And I'm going to take that one away from here. And I end up with 2x cosine 2x minus 2 sine 2x divided by x to the 3rd. So this is the derivative of this. There we go. Don't forget in all this what a derivative is, what this function will do for you. It will give you the slope of the tangent line to this function at any x that we choose to plug in. All right, so there's product and quotient rules, a couple good examples of each. Just be careful with them, watch your algebra mistakes, and you'll be fine. And these will really expand the number of things we can take derivatives of.